Okay, Eagles, this video is going to talk about the key values of trigonometric functions that we need to know mentally in this course. So hopefully this is a review, just a refresher for you. So first of all, we need to understand that in calculus, we are working in radian measure for angles. So we're not going to use degrees at all. It makes the calculations simpler to use radians. Now, mentally, you may think about angles and degrees, but be able to convert them into radians pretty quickly. So let's just go through this. What is a radian? A 1 radian angle is a central angle. That means it's an angle whose vertex is the center of a circle, okay? And that angle is going to intercept an arc of the circle. So this portion here is the arc of the circle that the angle intercepts, all right? And the length of this arc is the same as the radius of the circle in which we have drawn the angle, okay? So the radius of the circle is capital R. We are saying that the length of this arc is also capital R. If that's the case, then this angle has a measure of 1 radian. It's more of a natural way to measure angles using the radius of the circle. Now, mental conversions, okay? The perimeter of a circle, which we call the circumference, is equal to the radius of the circle times 2 pi. That's the definition from geometry class. So that means that there's going to be 2 pi 1 radian arcs that comprise the circumference of a circle, right? So you can see this here. Here's our 1 radian angle, right? So we have an arc that's equal to the radius of the circle. If we go around, there's going to be a little bit more than 6 of those. 1, 2, 3, 4, 5, 6, and a little bit extra to make up the circumference of the circle, right? So that means that there's going to be a little bit more than 6 of these 1 radian angles that go all the way around the circle. So we got 2 pi radians corresponds to 360 degrees. And so this equation lets you convert back and forth between degrees and radians. You may find that pi radians equals 180 degrees is easier to work with when you start to convert. So I still kind of mentally do this, right? But I know, for example, that, 2 pi or 2/3 pi radians goes to 120 degrees. So I don't really have to do the conversion anymore because I've done this so many times, and hopefully you'll get to that point at some point. If not, we can always start with this and then say, okay, what did I do to pi to get to 2/3 pi? I need to do the same thing to 180 degrees. Okay, now, definitions of the trig functions, post-geometry class, when we go past the 90-degree angle, right? So here we go. Let P be a point on the unit circle. That's a circle whose radius is 1 and whose center is the origin. And we have rotated P theta radians from 1, 0. So down here is 1, 0. We are rotating counterclockwise, okay, theta radians. So here's an angle theta, okay. We've rotated point P around the circle, that many radians, and now we are here, all right? So this is point P in this picture. And P could be any place on the circle. Just for the sake of illustrations, we're saying this is point P, right? Definitions. Sine of theta is the y-coordinate of point P. Right, so in this picture, the y-coordinate of this dot is the sine of angle theta. All I can tell you right now, without knowing what theta is that it's a positive number because the y-coordinate of this dot is a positive. Cosine of theta is the x-coordinate of point P, right? All I can tell you right now is that cosine of theta is going to be a negative number, right? Because the x-coordinate of this dot is a negative. And then tangent theta is the slope of the segment that goes from the origin here up to point P. Right? All I can tell you right now is that it's going to be a negative number because the slope of this line segment is negative. So those are the extended definitions for sine, cosine, and tangent. And the old definitions of ratios of sides still works if you're an acute angle, right? But we can't really talk about that when you go past acute angles because you don't have a right triangle anymore, right? Then you have these 3 definitions which are related, right? So we have cosecant of theta, CSC. That's the reciprocal of sine. Secant of theta is the reciprocal of the cosine. And cotangent of theta is the reciprocal of the tangent. So if you know these 3, you can get these 3 as long as you know which one goes with which. All right, so now, which ones do we need to know mentally? You need to know the multiples of 1/6 pi, which is 30 degrees. And you need to know the multiples of 1/4 pi, which is 45 degrees. So mentally, you make those conversions. Those are the ones we need to know. So we need to know 30, 60, 90, 120, 150, etc. We need to know 45, 90, 135, 180, etc. Okay? Sine, cosine, tangent, and all the others. Those angles. How are we supposed to know that? Okay, well, this goes back to geometry a little bit. So let's go through pi over 6 radians. Okay, we'll go through what we can figure out here. So here's point P. It's been rotated pi over 6 radians from 1, 0 around the circle, right, counterclockwise, right? And then we're going to talk about the coordinates and the slope of this dot. Okay, so the sine and the cosine depend on the coordinates of point P, and the tangent is the slope of this line segment. Okay, so we can figure those things out because of some geometry that we learned back in time. Pre-Cal 2, also maybe a geometry class. All right, so in this figure, we know that the radius of the circle is 1. So this line segment here is 1 unit long. If this is a pi over 6 radian angle or a 30-degree angle, then we know that the sides of this triangle that we get created here, the x-axis, are 1/2 vertical part and 1/2 square root of 3 for the horizontal part. If you need to review that, I'll make an explanation of those numbers in a separate video. This is the 30, 60, 90 right triangle. Very important mathematics. Okay? All right, so that means the coordinates in point P are 1/2 square root of 3, comma, 1/2. That helps us define these values. So the cosine of 1/6 pi is the x coordinate of point P. The sine of 1/6 pi is the y coordinate of point P. And the tangent of 1/6 pi is the slope of the line that goes from the origin to point P, okay, which would be, in this case, the y value divided by the x value, right? Rise over 1. Now, what it says up here is if you know quadrant 1, then you know a whole bunch more, right? A whole bunch of the other ones, okay? Because here's what you can do, right? You can reflect this point over the x-axis down to here, and the coordinates would be very similar, right? You just have a difference in sign. You could reflect that point over the y-axis over to here, and the coordinates would be similar, just differences in sign. And likewise, you could reflect that point over or through the origin down to here. Or you could think of it as I'm going over the y-axis first and then the x-axis, right? So if you know the cosine for pi over 6, I'm going to claim you also know it for 5/6 pi, it's over here, 7/6 pi here, or 11/6 pi. So it says here the values of these functions for 5/6 pi, 7/6 pi, 11/6 pi are the same, except for possible sign differences. Okay? So here we go. In quadrant 2, the x coordinates are negative. Slopes would be negative. Y values would still be positive. In quadrant 3, right down here, 7/6 pi, both x and y values are negative. And slope is going to be a positive. And in quadrant 4, over here, x values are positive, y values are negative, slope's going to be negative. So again, if you know just quadrant 1, you're going to get a whole bunch of these for free. So know quadrant 1 really well. All right, let's go through the pi over 4 angle. So we've rotated point P, right? Pi over 4 radians, 45 degrees from 1, 0. That puts us there, right? We can drop this line segment down here and look at this triangle here, right? This is a 45, 45, 90 right triangle from geometry class or pre-cal 2. So we know that this side is 1. If that's the case, then these two sides are the same. They're both 1/2 times the square root of 2. If you need to review that, I will make a separate video explaining where those numbers come. Okay? This allows us to now figure out trig values for pi/4 radians. Okay, again, the cosine of 1/4 pi is the x coordinate of this point P, 1/2 square root of 2. The sine of 1/4 pi is the y value of point P, 1/2 square root of 2. And the tangent of 1/4 pi is the slope of the line that goes from 0 to point P, right? That's going to be 1. Same rise and same run there. All right, again, if you know quadrant 1, okay, you're going to know values in all the other quadrants because you can just reflect over the x-axis, reflect over the y-axis, or reflect over both axes, i.e. reflect through the origin. Okay? The values are the same for these angles, 3/4 pi, which is up here, okay? 5/4 pi, which puts us down here, or 7/4 pi, which puts us down here, except sign differences. Okay? So, boom, 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 boom. Okay, numbers are the same, just know which quadrant you're in, and that changes the sign, the SIGN value, right? Negative versus positive. Okay, and then the only other thing is the poles, right? The poles are like, okay, 1, 0, right? 0 radians, pi halves radians, the North Pole, pi radians, west, 3/2 pi radians, south. Okay, so those are pretty simple, right? Those are just zeros and ones, and you just got to think about the definition just now. So if I'm at pi halves radians, it's my point P. The coordinates here are 0, 1, right? So the cosine of 1/2 pi is 0. The sine of 1/2 pi is 1. The tangent, the slope that goes from 0 up to point P, right, is undefined because it's a vertical line, right? So these values will always be zeros, ones, negative ones, or undefined. So you just got to think about where am I and apply the appropriate definition. Okay, so again, if you know quadrant 1, and I'm not going through pi/3 radians because that's the same 30, 60, 90 triangle. It's just now the vertical portion is longer than the horizontal portion. So the same numbers are going to show up there, right? But if you know quadrant 1, right, and you know the 4 poles, okay, then you will know the rest of it without having to draw the entire diagram every time, which to me is more efficient, all right? You may have to do that in the beginning, but eventually we want to get to the point where you just got to visualize quadrant 1, okay, and then which quadrant is my actual angle in. The numbers will be the same, just the signs might be different. Okay, so at some point, you're going to have to be able to do 80% correct, right, on questions like this, right? What's the sine of 11 pi over 6? Cosine of 3/2 pi. What's the cosecant of 5/4 pi? Right. So again, what am I thinking here? I'm thinking, okay, in quadrant 1, right, 1/6 pi, right, 30 degrees. What's the sine of a 30-degree angle? Well, it's 1/2. Okay, and then 11/6 pi is in quadrant 4, so the y values there are going to be negative, right? So negative 1/2 would be my answer here, right? And that's kind of the thought process you should go through, right? It should take you at some point, not very long, right? Not very long to be able to evaluate these because these are now smaller questions that pop up in a larger problem, right? So hopefully this review was helpful. Check out those other videos if you need some review on where the numbers and those special triangles come from. And hopefully you'll be able to conquer this real soon on your operational skills.